Yo, it's good. Hope you're doing well. Got a quick question for today. Pretty short, but kind of complex, if you will. Uh, yeah, so let's just get started. So, this question is asking the difference between paramagnetism and diamagnetism. I am pronouncing those words really wrong. Between two ions. Now, both of these ions, the metal charge is 2 plus, and I was just asking why is one of them paramagnetic and why is the other diamagnetic. So, to begin, uh, well, like, I don't know how should I start this. Yo, I'm lucky like not prepared, bro. So we know that both of these are Fe 2 plus on both of them, right? Because H2O is a charge of 0, so Fe 2 plus on the first one, and then cyanide gives a negative 6 charge, so iron has to be positive 2 on the second ion. So now what it's saying is that FeH2O 6 2 plus, or what's the proper name for it? Hexaquaferrate ion is paramagnetic, while cyanate hexacyanate ferrate ion is diamagnetic. What is the difference between the two? So the difference between these two actually lies in if like the strength of their field. So looking at the periodic table, or not periodic table, but looking at this formula sheet, with the reference being H2O. H2O is considered weak. So from here, that's weak, and then from here, that's strong. So here we can see that cyanide is a strong. So the cyano ligand is strong, and then what was the other one? H2O. This is a weak. So we can just note that down. Okay, so now the difference between these two, like strong and weak, lies in like the gap in between their like fields. So there's like a lot of like crazy work that goes into this, and I low-key don't really want to explain all that. Maybe in the tomorrow's video I'll explain it because I still don't fully understand it. But from what I understand, or what I know so far, is that we'll have, so like when we attach ligands, they'll split like based on like which is perpendicular. Like if we have an octahedral shape kind of like this, like, well, actually I'm not even gonna explain it, but I know I'm not gonna explain it correctly. But what's happening is like, yo, when we attach ligands, like some of the energy electron, like the electron levels get split, and that'll cause it to like low-key get messed up. So yo, that's like very very simple. I don't even know if that fully makes sense of what happens, like why these fields get formed. So for octahedral, we'll form 2 electron fields at the top and then 3 at the bottom. So now this field is going to be called EG, and then the bottom one is going to be T2G. And now this gap in between here, this is quite important. This is going to be the delta octahedral. Let's put oct. So now this is like kind of like a null drawing. Like this is like just basic. So for weak, this gap is going to be smaller. So change in oct, like change oct, well delta oct, is going to be smaller compared to a strong field ligand. I mean a strong ligand. So it'll kind of make sense in a bit. So let's just redraw this. EG T2G, and then we're gonna have strong here. This gap will be bigger, so I'll just make it visibly a larger gap. So this is gonna be change in delta oct and then delta octahedral. So clearly, what I hope you can see is that this delta is smaller than the other one. than that delta oct. So I'll just put this as weak delta oct strong. So now this gap or this change in energy will cause the electrons to be filled in a bit like different. So maybe something that, okay, so now we just need to fill in the electrons for these, and it'll kind of make sense. So I'll just like, okay, just weak, strong. Okay, so this is right at the electron configuration for iron 2 plus. So iron, just like neutral iron is going to be 4s2 3d6. So now if we take away 2 electrons from the 4s level, that'll just leave this as argon 3d6. So you have 3 electrons to fill in. Okay, so now let's just start with the weak field ligand, H2O. So we have 6 electrons, so we need to fill them in. 1, 2, 3. So now this level is close enough to level EG is close enough to T2G, in that the remaining electrons will fill in these higher levels before pairing up for that last one. So we'll have 1, 2, 3, 4, 5, 6. So that's what the weak field will look like. Now let's just do this. So wait, before I move on, you can see here that there are 4 unpaired electrons. That's a key difference. Now let's fill in the strong strong field ligand, which is cyano. So we got 1, 2, 3. But now the difference here is that delta octahedral is large, in that the electrons will not fill up into the EG level and will rather double up in the T2G level. So we got 1, 2, 1, 2, 3, 4, 5, 6. So in this case, we have 0 unpaired electrons. So now to answer the question that we have, which is explain the difference between why one is paramagnetic and one is diamagnetic. So this matches with what we observed. 4 unpaired electrons. This is paramagnetic. This is diamagnetic. So the difference between these two is just the strong field and weak field. So I guess we could simplify this by saying like H2O ligand is weak field and electrons will fill into EG level, while what my writing is so messy, Cn minus ligand is strong field and electrons will stay and pair in T2G level rather than jumping up to EG. So there you go. Pretty simple, relatively simple. I didn't get into the whole mechanics of it. Bro, it's snowing so much. What the heck? I thought it was spring, bro. Anyways, yeah, that's pretty much all pretty straightforward, I feel like. Bro, I had my 261 lab exam and it went so bad, bro. I actually emailed the coordinator, bro, because it was like, I actually thought it was a scam, but I don't know, see how that goes, bro. I was preparing so much for it and I just got molested, bro. I got messed up from that, bro. But anyways, that's all for today. I'll see you tomorrow, and hopefully see you tomorrow with a more of a like explanation for as to like how this splitting of energy levels occurs. I have another question based off of these energy level things, so I'll explain it within that probably. So yeah, that's all for today. I'll see you tomorrow. Bye.